hate you. Okay, go ahead.
I can do a quick introduction.
Yep, sure, go ahead.
Yeah, sure. So yeah, Adam Brack. I'm a MEng at UTIUS. Just started a couple weeks ago. Just moved here from Edmonton, actually.
Ooh, Edmonton.
Yeah. I drove across the country. It was yeah, it was pretty interesting actually. Got to see everything from Edmonton to Toronto. Yeah, that's pretty much who I am. Not too interesting, to be honest with you. Most interesting thing was the drive cross country. Yeah, sure. So yeah, Adam Brack.
Not gonna lie, that is pretty interesting thing, but I'm sure there's others.
Yeah. Just started. And it's nice to meet all of you.
Nice to meet you too.
Likewise.
Sorry, I'm just cleaning my never to be used glasses. Let's just. There we go. There, now I look like I know what I'm doing. I don't know what I'm doing. What about what, Erica? Oh. Now we have 8 minutes before we actually start, so.
I guess I'll answer Erica's question then to break the silence. Reason I was interested in this team, kind of multiple reasons, obviously, but first interested in space. I'm sure everyone on this team is interested in space exploration.
Yep.
Also super interested in robotics. That's what my MEng is in, is the emphasis in robotics. So those two things kind of together really pointed towards this team as a team to be part of. And yeah, that's pretty much also the awesome new logo.
Oh, yeah. Thank Mingshu for that.
Yeah.
Oh, Cyrus truly did align.
Yeah.
If this turned into a patch, you know, I swear, it'd be a very nice patch. Or stickers.
Sticker on my computer would be cool.
Yeah. Yeah. Does anyone else want to volunteer why they, you know, what made them interested in the team?
Recording in progress.
You know, before I start telling stories.
Recording stopped.
I could tell you, although it's pretty basic.
Go ahead.
I love robots and I love space. This is a great fusion of the two. Who saw that coming? Yeah, I know. Okay.
That's unacceptable. You copied Adam's answer.
I'll give you this. All right. How about this? I'll give you this. When I came looking at the events, I think it was during the open house, and there was Club Sarah sorts there. I talked to Dylan, the old president, and he did FRC as well. So we kind of talked about that too, and he said, yeah, this is kind of like a continuation of it, a little different in competition, but it's still a lot of fun, and you get to do a lot of the same stuff. So yeah, he kind of convinced me that this was the superior team to UTAT. So good for Dylan.
Yeah, I do recall basically the first day you came in, I was like, okay, go build me an arm. And that was your very first day. It was great. Of course, there was more guidance than that after that. Don't worry, but yeah, fun time.
Yeah.
Okay, people are starting to trickle in. That's good. 12:05. Do you want to elaborate that on that, Erica? I really don't understand what you're trying to say here.
It's about the people and the friends you make along the way, and that's what brought me to this team. Yeah, that's it.
Yeah, that's good. Whoa, 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 whoa. Okay. It is the first kickoff meeting, and we're already starting to antagonize me. No. Adam, I can assure you that I am the nicest out of all of these people. And to everyone else, I say that Chan is a filthy, filthy liar. The fact that Jeremy is laughing and has his audio off means nothing. I am incredibly nice. I'm the nicest person. Don't worry about it.
No. He is. He's a great person. He's rough
Oh,
around the edges, but he's
no, rough on no edge. I'm incredibly soft and nice. I don't know.
you know what? I'll take your word for it.
You know what, Erica? The first time we can get everyone into the My Hall Arena or back into the My Hall Arena and have an actual full in-person meeting, I will buy the entire team pineapple on pizza. Out of my own wallet.
That was meant to be a conversation starter.
I'm
okay,
allowed
that
to,
too.
wait, hold on. I'm allowed to expense that? I'm allowed to expense that? Oh my God, okay. So I don't have to spend my, okay, cool, awesome. It's a good
You
thing
probably
you
use
put
the
me,
Domino's coupons too.
you put me in charge of the budget. So yeah, it's a really good thing. Kenny, that is the breakfast of champions. $2 minutes. Whoa, hey, no, Nayab, come on. Coffee is amazing.
Nope. I agree with Nayab on this one.
No. I mean,
Coffee?
tea is okay. Coffee's just
No,
yeah.
bro. Stop it. Tea is the thing to go to for just normal times. If you're trying to just like stay up for some reason, then you drink coffee. Coffee sucks.
I drink
Sorry.
coffee casually. Coffee's delicious. I don't know about you.
I respect that
never
opinion.
had a bread latte or pumpkin pie.
Or an
I think my brother's had
espresso or man, my cat's not here. I can't show everyone my cat. I'm holding up 4 fingers, but multiply that by 10. It's all good. Just 4. I can't count. Yep. Okay. Yep. Slide. Yep. Okay.
Sure thing. Just before we start, there's no audio on the live stream, so Chan. And while he's fixing that, I guess I'll introduce myself. My name is Erica. I'm a Mech 223, so I'm third year mechanical engineering. And yeah, I've been on this team since first year. It's a great place to be. We do a lot of cool things, and especially in mechanical, which I'll talk about in a moment once Chen gets the audio working. Or yeah. Over quarantine, I picked up a lot of baking, and now I make bread on the occasional time, and it's bad. There's so many calories in so many things.
And she sends me pictures of it. It's great. It looks delicious. Yeah. It's not good for you if you're on a diet, though. So yeah.
Large amounts of bread.
Okay.
Great. Okay, so let's move on to the next slide for mechanical systems. So most of our work is like the actual physical work that we do for the rover, like all the physical components. So that would be the rocker bogie suspension, which is the drive mechanism. It's what keeps our rover able to like move over different terrain and just like adapt better to the Mars environment, or I guess the desert environment in our case. The wheels, those are all custom made in-house. So we do everything from the design to the manufacturing with our sponsor. And so that's one of our big hands-on projects. We look at different like tire designs, tire treads, like materials and sizes, just so we can adapt it best we can to like the desert. One of the big challenges there is grip, and like the balance between grip and like speed and stuff with and turning ability. So the more the grip increases, the less our turning, the more our turning decreases, because we're gripping too much on the ground. So that's one thing we've had trouble with in the past, and that's one thing we're looking to improve a little bit more. So that's one of our big projects. The battery bay. So we work a little bit with electrical on doing some of their more hard were physical components. So the battery bay was one big one, something to house all our batteries and their circuit boards. So making like something very secure, something easy to open and close, and something that's easy for us to use in competition while still being very robust and strong. And then we have all our chassis and auxiliary systems. So the chassis is the big box that holds everything together. That's one of our big projects. We work a lot with the science team and the electrical team to make sure that we can fit all of their components into the chassis, and we make sure that we don't get any sand or anything else into the chassis during competitions that could interfere with any of those delicate systems. So that's one of the big ones. And the chassis also attaches to the arm, so takes a lot of force and weight from that. So we have to make sure it's very stable and robust. There's also a differential bar, which is part of the chassis system, which keeps everything relatively level, relatively parallel to the ground, even if we're on like a really big rock or something with an incline. So that's also one of the big mechanical projects. And yeah, if you want to go to the next slide. Yeah, so our design phases usually look like pretty standard. So we start with conceptual design and research in the like fall semester-ish, and then we start moving into detailed design during the end of the fall semester and the beginning of the winter semester. We do a lot of 3D modeling in SolidWorks, and then we do also finite element analysis, which is basically just simulation of forces and stresses on our mechanisms. These are all like very industry standard, so it's a very valuable skill set to have if you're looking for a job or something, a career in this industry. So these are like all very applicable skills that we will teach you over the course of the semester and the year. And then during the winter semester, we do testing and assembly. So you'll get to actually go into the machine shop or the garage, and you'll be able to do like the hands-on manufacturing for what you've designed over the past while. I think this is one of the most rewarding parts about mechanical team. You take something that was like, an idea, you make it on SolidWorks, you make a 3D model, and then later you're able to like actually build it and bring it to life. And I think that's one of the really cool things about mechanical team. And yeah, so next slide, please. So yeah, this is one of the student machine shops we have available. So we have a bunch of tools and stuff like that we are able to use. They're not ours, but we're able to like borrow them from the facilities. We use a lot of like CAD, we use a lot of machine shop stuff like lathes, drill presses, lots of hands-on stuff. And then we also get manufacturers to do laser and water jet cutting, CNC milling, carbon fiber manufacturing and stuff like that for us as well. So you have a lot of these tools in your arsenal. Really whatever like you want to make it's possible to make with our team with the help of our sponsors and stuff like that. So whatever you really want to do is you can bring it to life, and you can kind of just like, we have a lot of things that can help you support you in doing that. Yeah, next slide, please. So yeah, as I mentioned a little bit earlier, you can expect to learn a lot of CAD and SolidWorks software skills and mechanical. So these are all like very industry standard. We will be using like Fusion 360 as well this year. So the CAD and mechanical simulation softwares, you'll learn more about like mechanical designs and the principles of like kinematics and dynamics and stuff like that as well as the hands-on skills for manufacturing and machining. We also use a lot of 3D printing, so you'll learn a lot about different manufacturing techniques like that as well. That's kind of what mechanical team does. There's a lot of hands-on components. So if you really just like tinkering with stuff, like working on stuff like in person and like getting your hands dirty and stuff like that, this is definitely where you'd want to be, I think. What the fuck?
I do not know where that came from. Okay.
That's not in the slides.
Okay. All right. There we go.
All right, I guess I will take it from here. So hello everyone, my name is Danny. I'm an NSci 2 and error option. I am the science or science team. Go to the next slide. So science, what do? Probably assume we do the science. We do the scientific experiments in competitions, as in all of our competitions, there's always a section that speaks to some sort of scientific mission on Mars. Sometimes it's analyzing Mars geological or geographical features, but for the most part, our challenges involve us collecting soil or rock samples and then analyzing them, usually for the evidence of life or lack thereof. Next challenge. I mean, next slide. So to give a little insight on some of the science missions that you've seen previously, RSX competes in 3 different competitions: CRC, ERC, and URC. So for ERC and CRC, they change every year, but for CRC in 2020, it was to investigate a promising region and evaluate it for a long-term or temporary settlement. So that was, again, analyzing some samples and then conducting some sort of research and analyzing for a specific metric. For ERC in 2020, it was to do analysis on the geological features of Mars and to design a scientific mission in that area. So it was more speaking to the geology and geography of Mars. And in 2019, it was to obtain surface and subsurface layers of soil. So that was a competition that we attended in person. And we designed a drill and collecting mechanism that you can see on the right, which was pretty fun. And finally, URC. URC does not change every year, and I would say it's probably one of the most competitive ones out of the 3, and it's what we've been focusing on for the past little while. The next slide. So what is URC? URC's science mission is to conduct in situ analysis on some rock samples and some soil samples to detect if there is life, if there was life, or if there's no life in the given sample. Go to the next slide. So based on our research, we have come up with a couple experiments, but just wanted to highlight our main 2, which are microscopy and fluorescence, or FAD. So microscopy is pretty self-explanatory. We're just taking a microscope, attaching it to a camera, and then looking at the samples. So we're looking for anything like, looks like a cell structure, so anything that looks like life as we know it. And I actually have our microscope camera system here. Looks pretty cool, kind of expensive. And the second one, fluorescence for FAD, is a little more complicated, but still relatively easy to understand. So it's essentially we're searching for FAD in samples. And for those of you who don't know, FAD is a coenzyme that's involved in the electron transport chain. And so essentially it helps boost the efficiency of ATP generation. So if we see FAD in a sample, it's a pretty good guarantee that there's life within that sample. So our experiment is to essentially excite the sample based on the excitation spectra of FAD. And we know what it should emit if there is FAD in that sample. And we have a PMT that absorbs and recognizes any of those photons that should be emitted if there is FAD within that sample. And so that being said, we can detect if there is life within soil samples. Go to the next slide. We also have some, yes. So this is our chassis. You can kind of see our carousel of test tubes on the far left on top, and on the bottom, our PMT is that big chunking 3D printed system. So that's analyzing the test tubes, and on top is the camera with a microscope. Yeah, it's a wet lab on a rover, which is pretty sick. Slide. And yeah, so those were our main 2 experiments, but we also have some other ones. I won't go over them because they would take too long, but essentially we're just either looking for fats or proteins. And with these experiments, we just need to look for a change of color, and we know that there exists those within that sample. But yeah, we go on to the next slide. Those have been the projects that we're currently working on, but there still is a lot of work to do for science. Like I had mentioned, CIRC and ERC change every year. So when those rules come out, you can expect to be working or starting a project from scratch. So you'll be able to do your research, do the entire design process, then build the system to carry out these experiments. which is really exciting. That being said, URC, we're still not done. We still have a bit of research to do. So the experiments I had mentioned are for URC, but they're more for soil samples. But for URC, we also have to collect or analyze rock samples. So we're doing some ongoing research on how to analyze for extinct, extent, and absence of life on rocks. And lastly, we also will need to physically build our experiments. So we have modeled and designed our system, but we have not gone in and actually put the things together since it has been virtual for the past year. So you can definitely look forward to bringing your mechie skills out and doing some physical design work. In addition to coding our hardware for our motors and our pumps to work. So we'll need to do some coding there. So next slide. What will you learn? Well, like I mentioned, kind of get to do a little bit of everything. There was software, mechanical, also get to involve yourself in electrical systems if you want to create some PCBs. It's a pretty well-rounded team. So if you want a little bit of exposure to everything, then I would say it's the perfect team to do that. In addition to also exposing yourself to scientific experiments and research in the space industry. So I think it's a good exposure to the kind of mentality that big space agencies or space companies have to go through when designing scientific missions, especially for detecting life. So yeah, next slide. Why join us? So I keep saying this, but we're a pretty well-rounded team. You can learn skills everywhere, really hone in on what you're good at, and also learn something new. You'll also be a part of a pretty important team as we are 1/3 of the competition points for URC. So you can find some comfort in knowing that you're really contributing to the success of the team by joining science. And we're a small team, so there's only three to four of us. But we have big vibes. We're a pretty chill team, pretty close. You can kind of see on the right, we have our science mascot. It was the spawn of a late night work session, or we just needed a break. But you know, we're a little bit silly. He's a little bit intimidating, but that's okay. He's what we all aspire to be. So yeah, we're just a group of space, bio, and rock nerds that come together to do research and design cool things. Yeah, his name is Science Chad. I don't know if I mentioned that. So yeah, if anything I've mentioned today resonates with you, I would highly recommend to join us. We'd love you. And one last thing I will mention is that our meetings take place from 3 to 4 p.m. on Saturdays. Most of this team has meetings on from noon to about 1:30, but we do 3 to 4, and that's just to accommodate for our scheduling of the members on our team. So yeah. That being said, I will pass it on to electrical team, Chris. Thank you.
Hi, everyone. My name is Chris. I'm a third-year ECE, and I'm the electrical lead for this RSX season. I'll discuss about the team, which is fundamentally the powerhouse for the entire rover. And so on the right, you can see there's a rover in action. Next slide, please. So first, I'll give a quick overview of some of the things you can get out of being a member of the electrical team. And then I'll get into some of the designs, or like the PCB designs our team has done in the past. And lastly, get some tips, give some tips to like see if you might be a good fit. Next slide, please. Next slide again. Yep. So as you can imagine, our rover is tasked with multiple challenges, whether it's to pick up objects with an arm, moving the rover from one place to another, or sensors that would aid the rover's ability to drive autonomously. So our team essentially uses like electrical components like resistors, capacitors, transistors to create schematics on PCBs or printed circuit boards that will drive current into these sensors, motors, and basically power the rover. We also do some work with antennas and wireless communication. Next slide, please. So now we'll get into some of the recent projects we have completed. Next slide. So first we have our PCB for the drive board, which supplies power to all the subsystems in a controlled manner and provides like a safe mechanism for distributing power to all the subsystems without starting like an electrical fire or meltdown, which is quite common. Um, next slide, please. We then have our low power board, which is used to step down the voltage for different components of the rover, and that's because they may have different power requirements. Next slide. And lastly, we have the ARM board, which takes input from an onboard computer in the form of electrical impulses and translates the signals into commands for the motors. And that could be things like rotating, gripping, and extending the arm. So the footprints that you just seen are all PCB designs, and I guess it will be much more interesting to manufacture them and see the real physical PCB that you can hold into your arm or hand. Sorry, I was confused with the arm. But yeah, I'd say this is just a footprint, but once you get to see your design in reality, it is a much better feeling. Next slide. So what exactly will you do? So when you receive like your first project, the first thing you'll do is scope the problem down to understand the functions of a particular component and limitations it might have in terms of like how much power it needs or like current and voltage to be supplied. Then you'll do your own research into like maybe like selecting feasible chips and select one that kind of satisfies most of your requirements. Then you'll begin to design your circuit for the chip and create a footprint or layout for the PCB in Altium software. Then the design will be manufactured once it's passed all the design rule checks, and you basically assemble and solder all the components onto your PCB. And this year, we also hope to give members more in-person hands-on experience with important circuit components and tools such as resistors, diodes, capacitors, multimeters, breadboards, and much more. Next slide.
Chris, is that a breadboard?
Yeah, I mean, it's just an image, but the guy was just drilling into a breadboard. Okay, so I'll just briefly mention the new projects for this year. And so they include the backplane board, power combo board, and new arm control board. And I guess once you join the team, you'll learn more about what they are. Next slide. So in terms of timeline, we'll first provide like all the necessary resources to learn the circuit design software and provide training for how to use, like safely use the various electrical equipment we have. And then you'll be working on projects throughout November and December. And hopefully we'll have our designs manufactured in January and February. We'll then assemble the electrical system in March and test the PCBs for competition, and lastly document the new projects before entering competitions in the summer. So as you can see, like kind of by the color code, you can expect to have work kind of intensify mostly in January, and that's pretty much to avoid having too much work during fall semester exam season or work ramping up in March and April in the winter semester. Next slide. So if you're thinking about electrical, you absolutely do not need any electrical engineering knowledge. We will provide all the resources you need. So we hope that the technical and hands-on projects will help you design your own PCBs for your own personal projects, and that you get like an appreciation for electrical engineering to be able to solve issues with, for example, hardware. And lastly, in terms of tips, I believe like the fundamental core of the electrical team is learning how to manage complexity and using abstractions to hide that complexity. And you'll learn more about like what that truly means if you do choose to work with our team. Like at first glance, when you look at our PCB examples, they may look kind of complicated and overwhelming, but essentially we just make small designs work and work our way up to making the bigger designs work. So just have like a growth mindset. You'll definitely see failure a couple of times, but don't give up, and you'll be able to improve your circuit designing skills. I mean, that goes for everything, but I guess it's more for like electrical, I guess. Next slide, please. In terms of my personal experience at RSX, I joined the team in my first year, and what I really liked about the electrical team was getting the chance to work with various equipment and tools, and I also liked being able to work on technical projects in collaboration with my teammates who are always very friendly and supportive. And I guess I'll leave it there and pass it on to software.
All right, thank you, Chris. So the software subteam is actually comprised of two separate divisions, software controls and software autonomy. The controls team is responsible for implementing the baseline software system for the rover that's used in all manually operated aspects of the competition, whereas the autonomy team is responsible for the design and implementation of the full autonomy system for the autonomous terrain traversal tasks in the competition. So that's just a quick overview of the software team in general. I'm just going to pass it on to Ellen, who's going to go over the controls side of things.
Thanks. So hey, I'm Ellen. I'm an ECE 2T2. So I'm currently on my PUI right now, and I'm the controls lead this year for RSX. So as Human said, the controls section of software team, we're responsible for essentially creating code that controls the rover's driving, turning, navigation. And we also work on things like simulation, visualization, and also graphical interfaces. And I can explain some of our current projects on the next slide. And the one after that. Thank you. So some of our current projects include creating a GUI program to combine map and drive controls into one program. So this uses like C++ and Python. And we also are aiming to enhancing our manual rover drive system. So this makes sure that we have really smooth control of the movement of the rover. So this includes, smooth acceleration and precise turning. So these are things that are really important when we're navigating through really rough terrain in our competitions. In terms of our current projects, we also have a project that aims to collect the rover's real-time position using GPS and the IMU sensor data, and then outputting that into a GUI program, which you can see on the right-hand side. We also have a project that aims to detect AR tags using AI and transfer learning to basically identify those AR tags from a camera feed. And in addition to that, we also have an ongoing project that aims to simulate the rover in rocky terrain with Gazebo. So overall, we have a pretty diverse set of projects, and there's definitely something for everyone if you decide to join the software team. In this team, you'll definitely learn a lot. Going on to the next slide. In this team, you'll definitely learn a lot of things that you can use in the future, whether it be, other design teams, other classes, or other jobs in the industry, especially in robotics research. So people in this team, we learn a lot of soft skills. So learning how to break a problem down that we have, scope it to fit our competitions or our multiple competitions, and then learning how to design a solution that would really work for, one specific competition or the next competition, or just any issues in the future, making sure that it's a long-term solution and we're not writing, bad code that essentially is a band-aid solution. So you'll really be in charge of programming, testing, and maintaining your own solution that you've created. So you'll definitely be, an expert in your work, and you'll know how to pass it on to the next person who might take over. So in terms of technical aspects, so we use a lot of ROS, so that's Robot Operating System, which is a library that's constantly being used in the robotics industry and in research. If you go through a robotics minor and major, you'll probably be using ROS in your classes or in your research. And the software controls team, at least, we primarily use a lot of C++ and Python. And again, like these two languages are commonly used in the industry. Which is super, super helpful when you're trying to find a job. And you'll also learn a lot about Git and Linux, and especially working with the command line. So in general, like a ton of these soft skills and these technical skills, they're super important and super useful if you want to go into the software industry in the future. you have a huge chance to, have hands-on experience with these languages and with these libraries through projects. And that's always like, the best way to learn, using like having like hands-on experience rather than just like reading from a textbook or anything like that. And so it's like an amazing way to really learn and to show companies or professors that you actually know how to write good code. So on to the next slide. So Controls is a super cool team to join if you're passionate or you're simply just interested in programming, AI, or software in general. We don't require anyone to have like a ton of experience, just to have, a lot of dedication and perseverance to join the team. As long as you show up and, you make the effort, we absolutely love to see that. We also have a really extensive onboarding process. So we have courses and tutorials and a lot of documentations to really help you learn as a stepping point. When I first joined the software team in my first year, I basically had like close to no coding experience. But I really put in the work to learn C++ through my classes in this club, and I was really able to have like a super strong foundation of languages. And so that really helps me with my classes and my PUI jobs, or in my extracurriculars, in my technical ones. So if you're interested, like, feel free to join. I'd love to have you. And if you're unsure about, which team to join, or you want to learn more about controls, definitely feel free to let me know. I'd definitely be happy to discuss. And I'll pass it on to Human to talk about the autonomy team at RSX.
Thanks, Ellen. So yeah, first off, I'm Human. I'm the autonomy lead. I am a first-year Master of Science student at UTIUS over at the Space Flight Laboratory, and I graduated from computer engineering in UFT last April. Now with that stuff out of the way, let's just get into the autonomy, software autonomy stuff, the cool stuff. So if you could go to the next slide, please, Adrian. All right, so in the competitions, the autonomy task is essentially a task for the rover to be able to autonomously traverse to posts or between gates through various types of terrain, so like easy or moderately difficult types of terrain. And so in order to do this, the autonomy subsystem, we're implementing this from the ground up, because it's the first time the RSX is actually doing this. And for that, we're having a proof of concept implementation by means of the mini rovers, which is the picture you're seeing on the right-hand side. And because it's a ground up implementation, that means there's going to be a lot of work in this area, because we're doing everything from scratch without too much experience from before. And that is what this mini rover is intended for. It's because we don't have too much access to the rover and we don't want to try autonomy algorithms on the actual rover. We're using this mini rover to test out our algorithms to make sure that our SLAM works or whatever works. So if you could just go to the next slide. And with that, that means that there's going to be a lot of trial and error, because the team and the dedicated members are going to be learning how to design and implement an autonomous system from the ground up. So you're going to be learning a bunch of different things in a vast array of areas. And don't worry about the picture on the right. I know it's small. It's just to illustrate the schematic for the mini rover, because you will be learning some electronics, sensor formation, state estimation, computer vision, software programming, and ROS, as well as many other things like Git, or just the normal stuff you're going to learn from a sub-team. The projects will continue to expand because, like I said, this is a first attempt. In the past summer, we collected resources to enable folks to be able to work on this stuff remotely, which includes various mini rovers and different types of computer equipment. So you're going to have a chance to work with those, get familiar with the industry standards like LiDAR or stereo vision or things like that, and really build yourself up as an autonomy engineer, which is very useful if you're trying to get into that area. And one thing I will mention is that because as a design team that is primarily focused on something that's kind of novel, there is some innovation that goes into it, and also what's the word? Like making sure that you have the initiatives, right? The initiative that goes into making sure that you go forward with the approach that you think is the best approach, and research that well, and then present it during the meetings. And so going off of that, who is software autonomy looking forward for in the next slide? This sub-team is really open to anyone who's open and eager to learn this stuff. The skills that you're going to need and the knowledge necessary is going to be picked up as the team goes on, the term goes on. Like Ellen said, there are some resources that we can offer by means like there's some Udemy courses that could be useful. And on top of that, the leads as well as the other members are going to be there to help you out. And generally speaking, the concepts you're going to be using, at least starting off, is not going to be too far of a jump from what you're likely learning in your undergrads courses if you're a little bit higher years, or if you're not higher years, there are things that you can find on the internet relatively easily, like machine learning, computer vision. If you Google that, a lot of stuff is going to come up. And so before I pass it off to the ARM team, on the next slide, I'm just going to go over a quick technical demo, which isn't really, I'm not going to demonstrate anything. I'm just going to show you some stuff, which will include going over the mini rover, one of the mini rovers, and highlighting some key components, as well as the Ooster LiDAR that we have and the Jetson Xavier. So I'll just start off with a LiDAR. So this is a Ooster OSO-32 LiDAR. It's quite an expensive bad boy, and we're lucky enough to be able to play with it for this year. This thing is capable of doing a 3D mapping of its surroundings. 3D mapping of its surroundings. So basically, there's going to be some lasers that get sent out from either side in all 360 directions, and it's going to map some field of view this way. And you're going to get that information on your NVIDIA Jetson or whatever computer you're using, and use that to say, okay, I know the depth of the stuff that's around me. What am I going to do with this information? How am I going to imbue the rover with some intelligence that's going to enable it to traverse through some difficult terrain? So that's one thing that we currently have and working on. The other thing I'm like I mentioned is the NVIDIA Jetson Xavier. This is a little bit more powerful version of the Jetson Nano, and it's basically capable of doing things that we will need it for this OSO LiDAR. The spec sheet is available online, but just to give you an overview, it has a bunch of different types of cores. It has a bunch of CUDA cores, and it has a lot of RAM, 8 gigabytes of RAM. So it's going to be useful when we're doing those intensive computations that require such computing capabilities. And moving on to a little bit of more of a, I guess, well, not that interesting, but this is the mini rover, one of the mini rovers. I'm putting my finger here because this is actually not attached, but I don't want it to fall. So this is one of the builds. It's one of the first builds, the mini rover. On the back, I'm not sure how well you can see it, but on the back, there's the Raspberry Pi 4B that we're using as the main computer, and some power supplies for the Raspberry Pi and also the encoders and such. The thing in the front is a stereo vision camera, which for those of you that don't know, and again, all of this stuff, if anything I'm saying, you're like, oh, whoa, I'm not familiar with that. Don't worry, you're going to become familiar if you do decide to join the autonomy sub-team. But the stereo vision is essentially a type of camera that emulates how a human eye operates. You have two cameras on either side, you know the distance between the two of them, and you see something far away and you can calculate how far that is from you, the depth of that image. And that's the kind of information it's going to be giving you on the computer. And also on the bottom layer, there's wheel encoders, there's a motor driver, and just motors and stuff. So that's that. All right, with that, I'm going to pass it off to ARM. But before I do, I would like to mention that this team is going to be incredibly useful for you if you're the type of person who wants to get into autonomy and machine learning side of things. But like you can guess already, there is some overlap with the controls team. So some of the projects that the controls people are working on are going to be tied into some of the stuff that the autonomy team is working on. And likewise, so if you're not sure about what to join between autonomy versus controls, I would recommend that you just come to the software overall meeting and you'll pick things up and you're free to transition between various tasks from autonomy and to controls. All right, so thanks for listening. I'm going to pass it off to Jeremy.
Awesome, thank you. So yeah, as Milan introduced, my name is Jeremy. I'm a Mech 2T3, and I'm the ARM team lead. So just before we go to the next slide, a little introduction to ARM. Just take a summary, the general gist of all the other subgroups or subteams you've just heard, and kind of mash it into one giant robotic arm, and you have the ARM team. Next slide. Hello? Oh, thank you. So yeah, what do? We build an arm that does a lot of the manipulation, a lot of the tasks for the rover at all of the different competitions. I know, for example, at the URC, there's an entire panel that we get to play with, which is really fun. We mostly deal with the electrical circuits for the arm, again, specifically for the arm. communications and software for the arm, and mechanical design for the arm. Everything we do that involves other fields, so software, electrical, and mechanical, is all related to the arm. We're our own little island, but we have a lot of communication with all of the other design teams. So yeah, next slide, please. As I mentioned briefly earlier, there's a few different tasks that the ARM does. This is specifically for the URC, I believe. Equipment servicing is, there's essentially a giant control panel, which is supposed to emulate a control panel of a rocket ship. So there's dials that we have to turn, levers to flick. There's actually one task where you have to grab a screwdriver with the arm, either grab a screwdriver or have one that's on there and tighten a bolt, which is fairly difficult if you can imagine maneuvering a giant 5 or 6 axis robotic arm using a gripper to grab a screwdriver and then turning a tiny screw after lining up for it. So that is one of the tasks we have to design for, and we have entire documents, sheets, and Google folders dedicated to how to do this, the design process on what is needed for this, what materials, what motors are out there that we can A, afford, B, within our weight limit, and C, know how to use in order to accomplish these tasks. The other challenge is extreme retrieval. We have to, this is kind of in partner with the rest of Rover a lot, because we have to go over some rough terrain to retrieve, I believe it's a water bottle of sorts. Yeah, I'm not entirely sure. I have actually never been to the competition myself, but hopefully that's going to change this year. Yeah, and retrieve a heavy object. So not only does the arm have to be precise, it has to be very strong. Next slide, please. So what are we working on now? The ARM team is currently in the process of redesigning the entire arm. So what you see on screen is the old arm, and it's, yeah, as you can see, it's not perfect, it's not super pretty, but it got the job done. What we want to do is just make a few improvements. Currently, we over the past quarantine, and we've been working on the mechanical portion of it. Over the summer, we started working on the electrical and software side of things. So we have finished a CAD model for the arm, within minor adjustments and changes if any such should arise. However, we still haven't finished constructing it. After all, we haven't exactly had access to any materials in person. So that will be our next thing. So if you do join ARM team and you like building stuff, yeah, it's a good idea to join ARM team then. Yeah, we will be doing that. And currently we have 2 sub teams, which afterwards in the Q&A, you can come over and ask any questions about the embedded and modeling teams. The embedded team is working with microcontrollers, and they will be the ones who get the feedback from encoders and send it to the motors, essentially, which they bridge the gap between the actual mechanical arm and the software side of things, which is the modeling team. Modeling team is using inverse kinematics to figure out where the arm has to go based off of where it is now. This should make it easier for us to control the arm. Rather than having joysticks, we can actually just tell it where to go and have the computer do it for us, which is very nice. Next slide, please. So is the ARM team a good fit for you? Well, I'm just going to go out and say yes, because we have a large variety of things that you can work on. And even if you're not super fond of something, maybe you don't want to, you're not super interested in it, but you think, hey, maybe I'd like to give this a go. Or maybe you're really good at, say, mechanical design, but you're interested in electrical or software, then ARM team is also a good fit for you, because you can get a taste of that without having to go into too much detail with it, and you still get to get a taste of everything. Is essentially it. You get a taste of everything, and you get to work on a lot of different projects. There is absolutely no prior experience needed. please just come and join, and we will teach you whatever you need to know. Believe me, I'm the modeling and embedded teams. I know only a little bit about microcontrollers, and I know nothing about ROS, which is part of what we've been using for modeling. And but we've been learning it over the summer, and it's been fun. It's been a lot of work, but a lot of fun things are. Yeah, another reason is we get to build things. You get hands-on experience, hands-on engineering experience, which is hard to come by. And this year we should be doing a lot of it with the whole constructing a new ARM thing. So yeah, next slide, please. So as you may recognize, this person right here is our administrative president, John. This is, I guess, a little bit about him. Yeah, so he's actually been to competition. I don't know if he wants to give a quick 2 seconds about it. But yeah, this is an interesting picture of him here. As you can see, the arm is very dexterous. Just be careful when using it.
Yeah, if you want me to say a quick 2 seconds, I can, Jeremy, if you'd like.
Yeah, please.
Yeah, quick 2 seconds. ARM team's the first team that I ever started off with. I joined RSX in second year, and I've learned quite a bit. I went from a mere second year ECE with absolutely no practical knowledge and no way to apply it, to someone who was, learning how to create a daisy chain to control an entire rover arm. And I also got to go to different competitions all around the world and actually pilot this thing to pick up different objects, use this thing to turn dials, push buttons, etc., and learn some really, really cool robotics. And I can't believe I'm saying this, learn some really, really, really cool math involved in robotics. You can call me a nerd anytime you like. I will take the compliment. But ARM team is that kind of team where the intersection of all three aspects of like mechanical, software, and electrical design all meet. And honestly, it is some of the most fun that I've had in my university career. Being on the ARM team is a great time. And Jeremy, I think, is a great leader. So, yeah.
Hey, thank you. Awesome. Next slide, please. So yeah, just before we wrap up, a couple projects ARM is also working on other than the complete overhaul of the ARM. We're working on a drill. This is mostly to do with science, as well as a shovel, which will be a kind of attachment for the end effector or the gripper or whatever you want to call it, which we're currently in the process of prototyping. And finally, a control center, a battle station, if you will, for controlling the ARM. This is still very much in early phases of development, but we'll be getting more into it as the competitions approach. Next slide. And now I'll pass it off to marketing and outreach. Yeah.
Yes, that is moi. Okay, so marketing and outreach, the other side of things. So basically the non-technical side of things for RSX. So what do we do at marketing and outreach? So we're responsible for talking to different companies and organizations, basically asking them for like different sponsorships, different maybe like deals and agreements that we can have with different teams. Organizations it's actually a very important part of this experience. I know, for example, for the autonomy team, the Ooster did get sponsored, and they did reduce the cost by quite a bit. So that's how we were kind of able to afford that. We also do web design, where we were basically overhauling the entire website and basically trying to get it up and running this year. That's our goal for this year. And lastly, Seek. So Seek is a competition that we hosted basically every year for university students, as well as Seek Junior, which was hosted for high school students. It was a competition that RSX hosted basically to help teach like different university students and high school students about robotics and get them interested in it. With the current atmosphere right now, we're probably not looking to do it this year, but we will be thinking of doing it next year. So that's basically what marketing and outreach is. Basically, reaching out to sponsors, as well as reaching out and creating websites and web design. So if you're interested in any of that, would highly recommend, because it is extremely important work. We really wouldn't be here without our sponsors. They provide us some of the metal cutting, some of the equipment that we use. As well as, I mean, a website is incredibly important just to get our name out there. So, if you're interested in any of that, please don't hesitate.
Yeah, so how do you join the team? I know there was a question about that in the YouTube chat. So basically, we are recruiting for all sub-teams that you've heard from today. And within the sub-teams, there's also potential leads, junior leads that help out with organizing and leading the team. Yeah, so we have a form that's available. I think John will post a link to that soon. And yeah, other than that, we meet on Saturdays at noon. If we were in person, we would meet in the My Hall basement. But as that's not available to us right now, we meet online on Discord. Can I get the next slide? So we meet at noon, except for science, which meets at 3 or 4. Each meeting is around half an hour to an hour, and everybody is welcome to join. Yeah. So thanks everyone for coming. We will post a link to our Discord where we will hold a Q&A session with each of the sub-team leads. Just feel free to join. That Discord is the Discord where we do all our work. So once you join, you can just stay. We do ask that everyone change their Discord name to their real name. But yeah, other than that, we will post a link to that everywhere it needs to go.
Just 1 minute. 1 minute. I am an old man who doesn't understand how linking works. Let's see here. Oh, there it is. Yes, there we go. To the chat. Okay, thanks, Erica. Thank you, Vedant. Oh my gosh. Okay. So it seems like, there we go. The link is now posted. And just some closing. Wow, that's water. Sorry, just some closing remarks. This is a great team to join if you have basically no experience. As I said before, when I was talking about my experience with the ARM team, I've been in RSX since like my second year, and it has been honestly the thing that's been getting me through my university experience. It is what's basically allowed me to get a job. Just talking about all of my RSX experience, and honestly, no, it's not even any of that that makes this the best. It's the people that are around me at RSX. Some of the most amazing people that I've met, and some of the best friends that I've kept, I've met through RSX. So if there's any endorsement that I could make, it's join RSX for the people. It's join RSX for the experience that you're about to have. And with that, please join the Discord and ask your questions. Unfortunately, I think Erica unfortunately will have to go, so I think Mech team might have might not be able to fulfill a Q&A.
Yeah, so I need to leave in like 5 minutes. So I can do a really quick Q&A, but if you're interested and you have any questions, just drop a question in either mechanical or DM me.
Yeah.
And I will be happy to answer. If you would like to talk like either in person or online sometime else, I can also set up a call with you. If anything, you could also just show up next week and we'll start talking about mechanical and doing like project delegation. So that'll be like our first big mechanical meeting with the rest of the members.
And with that, there's no one who has any questions for me. Well, actually, if you have a question for me, just drop it in the Discord. Honestly, I'll answer. But
Before we sign off,
Yeah.
so for the software meeting and Q&A session, that's going to happen over Zoom, and I'm going to be sending a link to join an invitation in the rover_software channel in the Discord. So once you join, you should see that, and then click on the link, and I'll see you there.
Wait, I'm on mute. I'm so old. Okay. He says with the Kumon here. Anyways, when Jeremy said I was not a nice person, he meant it. I am not a nice person. Sheesh. Okay. With that, we'll be signing off. Please ask your questions in the Discord. And yeah, it's lovely to have you all here, and I hope to see you in the future.
Yeah.
Welcome to RSX.
Thank you everyone for coming, and I'll see you there.
Bye, folks.